Okay, so let me tell you what I'm going to do today. I will install, I'm going to basically write my first assembly program, sudo apt update, sudo apt update, what's the passing this? So the idea is to write my first assembly code. Somehow, somewhere, I don't know. I've never written assembly ever in my life. This is the first time. Also, I will try not to use AI and try to do it as much as I could by myself. So clear this. I think is there some what documentation do I need? ASM nano hello.asm. What is this? New file? Okay, why am I using this? Justify replace. Can I type again type stuff? Yeah, I'm here. Save is control plus O, enter control plus SX. That's how you compile it, and then that is how you run it. Okay, let me just write. I just said I'm not going to use AI and I'm just doing it right now. But anyways, section data dot data. It's message db hello from assembly. A should have been capital. So right now I think len equal. I was about to say like it doesn't look anything weird so far. I mean I'm on the only 2 or 3 lines in, whatever. Then this is section dot text. What is everything going in? I have a global variable that is start underscore start. Then I have this underscore start. That's okay. I think I'm indenting a bit too much. Yeah, a bit too much of four indent. Indentation should be four. It goes to 80 default. Whatever. For the sake of it, I'm going to keep it 8. Let's move RAX, comma 1. Move RDI, comma 1. Move RSI message. What is the message? This is the message. We will move RDX. Have I defined RDX? I haven't for the length. Then it was syscall, the system call. Okay, I'm just blindly copying this and hoping I will figure something out. Zor, what am I zoring? Why is there a zor here? Now, that's it. Control O, enter, control X. Something. Oh, okay, that makes sense. Let's just save the file. That dash F. It's ELF64 hello dot assembly. Error instruction. Our list nano hello.asm. Shit. How do you exit control X? Yes. And no, wait, what was the output? I did NASM slash dash F ELF64 hello.asm. And it tells me this. But okay, my bad. My bad. Where's the cursor? Just move and move. So control O, enter control X. I run this. It compiled. And how do you run this? LD, hello. So this is the object file, and I'm naming it hello just to execute hello. That's it. That's interesting. Okay, what happened? Now that just tell me what happened. So I created a file that was nano hello.asm. I mean hello.asm was the file, nano is the command. The, this is the section for all the data that I need. So I think here is where I'm going to define the variables alongside the length. How is the length actually 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not. Then what is this 10? So you convert the code into machine code. This builds the executable. So this is a linker that builds the executable. And then that gives me a file. So means I have it right now. So this is a, if I clear all this and I just do list remove dash rf for hello. Ah, that's fine. And I have register dot slash hello. It says this. Hmm. Compiler Explorer, I've used this before. Okay, how, what do I want? I want to write a for loop. Is there any document? Did mention some documentation about the online x86 assembly compiler. I need some place to read it. Need some documentation and the basics of this. I just said I'm not going to use AI and now I'm just using it. Am I even recording? I think I am. Yeah, I'm recording. On this, I need this. X8064 registers. X64 assembly code uses 16 64-bit registers additionally. So you have 64-bit registers and you have 16 of them. Okay. Additionally, the lower bytes of some of these registers may be accessed independently as 32, 16, or 8-bit registers. The register names are as follows. So let's just match this from our hello, whatever the name of the file was. What was the file? Nano hello.tsl. So I have moved RAX. Did I use RS? I did use RAX. Hmm. So RAX is an 8-byte register. RDI is RDI. RDI is also 8-byte register. So I took one register and moved something. Okay, wait, let me ask this to explain this code. How do I copy everything? Will this work? After explain this code. Oh, fuck. I didn't need that. Explain the code that you keep, whatever. This program does only two things, that is print text and exit. That's it. The data section. This tells the assembler the following things are stored in data. Are stored data. So everything over here is data that needs to be stored. All right. This tells the assembler think strings constants arrays equivalent ish to string message. Hello from assembly. Alright, that's fine. It bytes in memory. How many bytes do I need? So is it 2 bytes? It must be right. Um, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Half a byte? Why do you need 10 bytes? This tells me define the byte. So this is not database, it's defined bytes. Of course it is. Hello from assembly is the ASCII. Oh, 10 is ASCII code for new line. Huh. So inside this section, this tells me what kind of the data I'm going to store. This tells the compiler to allocate some memory to it. This is the actual data that I'm storing. And then this is 10, which is the ASCII value of a new line, a 0 bytes. All right. This calculates the string length. So length equal dollar dash message MSG. Define a constant. Current position minus start position. So message is where everything starts, means H, and then okay. Oh wait, you guys cannot actually see the cursor. I think. Can you see the cursor? How do you even check? I don't know. I'm pretty sure cursor is not visible. It's not visible. Okay. Then the code section, the text, executable instructions. Oh, I mean, it makes sense because I defined a global start here. I'm assuming this is a variable. Start to the linker. Okay. This is where the execution begins. Uh-huh. Put value 1 into the register. Right. Um, RAX stores syscall number. You're storing one, then RDI is also storing one. What is RDI doing? Stores first system called argument. So whatever I'm sending it, like whatever data I'm sending it, that is what RDI is storing. Wait, what? RAX, RAX, whatever is an 8-byte register which will store the system call number. All right, you store the system call number. You store the system call argument, file descriptor. What the hell is a file descriptor? Let me Google Gemini it. It's actually pretty cool. This Google AI mode is cool for quick searches. A file descriptor is a non-negative integer used by Unix like OS to uniquely identify and manage an input-output resource within a process. It's just a bunch of tables. Non-negative integer, and I just called it a table. Anyways, all of these registers are system calls. So they are doing something directly with the memory, I think. Let me just pile up whatever I have to ask. All these are syscall related, not syscall related. Mm, I need you to explain me assembly's basic code and structure like another high level, like some other high level language. Assembly is basically an ultra minimal language where everything is manual. Makes sense. Okay, now let me just code up another file. How do you exit? Control X. We create nano for loop. Will this work? Maybe. So what am I going to define here? I'm going to need a, I don't know what I need. The first place was storing the data. But how was I storing the data? I am not sure. Should have opened it in split screen. It was faster. Where is this bloody code section dot data? Okay, this is the data, and I need four tabs. What data do I even have? I don't have any data. And then there's going to be a section dot text. Now, how do you start with this stuff? C++ int x equals to 5. Move rx. Put value 5 into register x. Uh-huh. Address. So what did I just do? Somebody asks me, not move, it's move, that's 5. Add x, comma. I think then what needs to be done, like the best practice as far as I'm aware, is to, no, rax is a register, right? There's no variables. You need a pointer technically to this, this value. How do I get that? It's a comma, okay. Can I directly do this? So it's add rax to 1 in my case. Initialized variables. Num dq5. Okay. dq is defined forward. What is a forward? Stores in 64-bit integer. So you'll have what? Hmm? You'll have a message. I don't need a message. I only need a num dq that is 10. Oh, in my case. Uninitialized variables. And obviously you do need um, a section start stuff. Like this global underscore start stuff. Underscore start. Then you can do a lot of stuff. This is the entry point. Then you can do whatever you want. Okay. Move copies the data. Addition adds the data. Subtraction subtracts the data. And then there's the increment and decrement, which I might use. Registers are tiny CPU storage looking things and superfast variable. It never told me about JE, and now it's using JE here. It's CMP compare jump is equal. this is what I wanted to do. How does loops work? Underneath. Yes, you do initialize a variable. You compare that variable with its with the like the maximum output that at the maximum the number of iterations it can perform. Accordingly, you jump to the code. That's I know that. You jump to the jump back to this for loop after comparison. So move RCX 0. Okay, this defines jump loop. What's JL? J less than probably. So everything is just instructions, small letters, 2 or 3 letters that define the entire behavior for a register. That's interesting. Okay, let's run this. Section dot text has not a space, 4 spaces. It's global underscore start. It's the only variable. Start. You move RCX, move 0 into RTA, RCX. Then you start a loop. So this is the starting of the loop. Inc RCX, which is incrementing. Then compare the RCX. Is this a single tab now? It's not. Let me just make it a single tab. Then you come slightly annoying, slightly annoying. But then you compare RCX with whatever the value I want. I'm just gonna make it 10. Then you jump loop, jump if less, and I think this is what JL does. JL is jump if less. So it's less. It's less than equal to JLE. That's simple. That is actually simple than I thought. Should be this. Full colon, not a semicolon. What happens next? You move RAX 60 into RAX. RAX, not RCX. Okay. Move 60. What is this XOR after every single whatever this execution? And then you do a syscall. Then I have to build it. How do I build it? Was control or enter control X. Then the commands were don't remember. LD NASM hello.asm. So for loop.asm, and then the LD command for the linker are not hello.codes. Now I can just run this. Hmm. Why are you not working? Isn't this how I was running dot hello? This works. Am I not printing it? I print. I have to print the numbers as well. I think I'm not printing the numbers. The fuck? Ah, you still move it. You still have that global start. You have the start, you move it, then you start the loop, and then you delete almost everything. I should have opened this in Neo, then this would have been faster. Actually, why am I even doing this in Nano? All things. No. You just name and for you. Yes. That's better. Okay. Just remove. You have to select all of this and then you can delete this. That's faster. Let's start. From start, and move 0 to RCX. Then I add RAX 0 to some other register. I move this digit. Wait, what is even happening? I'm not okay now. I'm just blindly copying it because there's not an option. You moved 0 into RCX. You moved the ASCII of 0 into RAX. So I think different type of registers for different sorts of input data. I'm assuming. And what is this AL? I have no idea what this AL is. Um, Move RDI. Why am I constantly adding this E? Move 1 to RAX, then move 1 to RDI, then move RSI, digit into RSI. What is the digit? I don't know what the digit is. Probably this. This I know. Then you move RDX, 1 to RDX. But this, I have no idea what is happening. Just made, then you make a system call. Move 1 to RX. You add RCX. I mean, add 1 to RCX. You compare the value of RCX with, I'm just gonna make it 10. Then you jump if less than equal to, back to loop of start. Then move RAX 60. What is this last, like this last bit? It's repeating everywhere. What is this bit doing here? It's repeating everywhere. And I still don't remember. Zor. It's definitely Zor is definitely just the Zor of like whatever numbers it is. A normal Zor, like how I do in any other programming language. Programming language. Just having fun. What is BSS? I think BSS was uninitialized variables. I could be wrong though. Digit RESB1, RESB1, whatever that means. Is this adding? This might be adding, but adding what? That's the question. Okay, break it down later. Let me just first tell you what is the system. I should have written what this part. Linux syscalls use registers to receive arguments. So the software that the system calls, whatever the syscall does, it directly access the value of the register. Is that what it's trying to say? Okay, the access syscall number, whatever. So yes, there can be multiple system calls. I can have multiple instructions that are going to be executed in a single block or in different blocks, or all those blocks might be connected to one another, and then they're only going to be called when there's a specific argument that I want, I guess. So RDI is the first argument, RSI is the second argument. I have not used it. No, I have used RSI. RDI is the first argument, RSI is the second argument, and RDX is the third argument. Then R10, R whatever, however many arguments I have. Okay. Then I have move RAX view 1. This is the system call. This is called 1 equals right. You write something something. But how do you even compile this W? Not this W. This I have the stuff. Hmm. NASM-F ELF64 for loop.asm. Implicit warning record ABS loop start is not defined. I have not defined the loop start of the loop. Interesting. When did I miss that? I see. Move RCX, you go loop start, you move to 0 into RCX into RAX. Then this works. Something has been deprecated, depreciated, whatever. Then it is linker for this. Yes. But what do I have right now? Okay, if I remove for loop, can I remove two files at once? I don't know. I'm not even gonna bother trying. Now let me list. I'm left with this. I am going to compile this, the for loop file. I'm then going to check again. Well, what did I have to check what file? Okay, now I have a for loop dot o, the object file. Oh, yeah, I mean, yeah, compiling gives me the object file. That's obvious. You then provide a linker to this. Using LD, you take a linker for the object file. Then you give it a name. To the executable file, I'm assuming that should work. And now if I list, wait a minute. EAR, not fuck this. Okay. For loop.asm, I could just run now. Nothing. Okay, there's only 0. I think I'm missing a lot of code here. Loop.ac. I'm missing a bunch of code somewhere. Make a syscall. Why did I entirely just miss this? Did I miss this or what? Anyways, let's move like what? Move RX one to RX. You move one to RDI, and move a new line. What is a new line? I mean, maybe a new line. Like, how does it know that you have to change? Take the cursor to the next line. That was the question because right now the only thing I've done is by directly doing stuff to the registers. All of these are registers, right? So how is there a new line here? That's what's confusing me. Make another system call. Oh my god, I didn't that I recognize that. Am I missing anything? RDA, and I'm not. Do the same stuff again. Compile this. Warning, default new line is not defined. Where is new line? The new line is not defined. New line was defined because the code fucking changed. Open nvim. Where is it? 33K. I love NeoVim. Section dot data. Oh, that's interesting. Dude, just shut up. It's like hampering me with dates. Huh. NASM dash ALF64. I don't know what ALF64 is doing. Opcode and operands. Invalid combination of opcode and operands. That is interesting. Let's match it line by line from the beginning. I go to 7K and I start it. Section dot data new line db10. That checks out. Section dot text global underscore start. That checks out. I have a underscore start. Move RCF0 checks out. Start the loop. Loop underscore start. Okay, maybe the indentation is bad, but I don't think it matters. You move RCX into RAX. You move the ASCII of 0 into RAX. You move AS to digits, whatever that this digit is defining. Move 1 into RAX, 1 into RDI, digit into RSI, 1 into RDX, and then you do a system call. Uh-huh, that's fine. Then what? Then move 1 into RAX, 1 into RDI, a new line, RDX1 system call. That works. I have an int RCX. I compare it with something. I think JLE might be. This shouldn't cause an issue, right? I doubt it does. But then it's move 16 to RS, RDI solve with RDI, and then you do a system call. And there is section.bss. I doubt this fixed it. Mhm. That's why. Also, the increment RCS makes sense. Why would there be an ink? I mean, an int in this. I'm recording, right? I'm recording. Okay. Even with AI, I'm up to 40 minutes of recording. That's interesting. That worked. Then you do the linker stuff. It's LD. I think I just moved the command dash o into an objected of whatever file. Or it for dash loop. And then just run this. I'm gonna clear everything out first. This for dash. There's only 1 0. Better modder version, sure. But there is still only right now it only prints 0. That's the thing. Only prints 0. My logic is not what it's telling me your loop logic is correct. The problem is this. I didn't use RCX, you told me to use RCX. That's the what your counter gets corrupted. Working version. I don't want to write this again. RBX. We just replace RBX. I was so happy it was going to work. As usual, disappointed. There is some assembly code or like someone who knows about assembly accidentally watches this. Just ignore what I'm doing. I'm just trying to have some fun. Pathetic life I know. Default free REL, whatever this does. Hey, if I this is makes sense. You just make V2. Um, I think it's making it's making all the RCX into RBX. It's called system call. Did I learn anything new so far? A bit. Well, the abstraction now makes sense about how loops work. I still don't know what this new line does. Compare RBX again. Loop start, XOR move 60 to RAX or RDRDS is called. Why this works? Sure, let's see. Will this work? Or is it going to be disappointment as usual? This worked, nice. This is what this is how low it gets. I'm asking this to ChatGPT. Let me just open the file again. Okay, let me tell it what I think is happening. Dot data has a new line db10. That means define 10 bytes. Okay. I have no idea what new line does. No idea what new line does, but it's there. The text defines, well, the code, I guess. The start is where the stuff is happening. The start is where the logic is happening. Logic is happening. I think I need all the registers. Um, the basic type of cs.round.edu. Okay, so the basic type of operand specifiers are below the following table. What table? This table. And value I am here. I have no idea what this is doing. Move source to destination. Push source onto the stack. Move source. Push source onto the stack. Move source to destination. There's so much stuff in this cheat sheet, x64 cheat sheet, and even then it's like, I mean, there's a cheat sheet. What am I even expecting? I'm seeing stuff that I've never seen before. But one thing I'm realizing, it's kind of like English, but where you have to keep a lot of logic in your mind, or somewhere like the logic has to be correct, and then it becomes a bit easier to implement in assembly. Uh-huh. Anyways, I see what is happening up until here. Then increment it. Then you compare the value of RBX. Define one byte whose value is 10. What does that mean? How do you define a byte and then you tell that the value is 10? Like its value is 10. So, okay, so the value inside that byte that I'm defining. Okay, okay, that makes sense. It's directly a pointer. New line is directly a pointer to a block in the memory that has 10 in it, and 10 is the ASCII value of slash n for new line backslash n. Why is it backslash? Like sometimes I would be typing in C++. I recently started doing C++ and CP. So I would do slash n, backslash n. It's kind of annoying to reach. I just, I don't know, whatever. It's not the value 10, it's also the address. So there's a byte somewhere that is storing 10, and then new line is pointing to that byte, the address of that byte, not the value 10. Okay, that makes sense. This tells start to the linker. This is the start where the program starts. I'm the main. Data is initialized variables. BSS is uninitialized variables. The text is executable instructions. Okay, this was a fun little project. I mean, I didn't do anything by myself, but it's actually kind of cool to touch these registers. That sounded weird, but whatever. Can you explain, can ChatGPT, let me ask, can explain me what is happening inside start? Happening inside of the loop underscore start. I have the loop. Suppose copy value from RBX to RAX. Sure. So it's 3 plus 0. That gives me the ASCII value of 3. Okay. You are adding RAX. That gives me the ASCII value. Okay. This stores character into memory. But I'd never defined AL or never did anything with AL. So it means lowest 8 bits of racks. Mm-hmm. Oh, this is preparing the print stuff. This is where it's getting printed in these 5 lines. And okay, so you do this, you do some stuff in the first couple of lines, then tell it what needs to be printed out. So here it is the digit, whatever I stored after adding it to the, that makes sense. Whatever I added in the memory position, memory location, I print that, then I print a new line, and then I increment RBX, and then I compare it with 10, and then as if it's less than 10, the result is less than 10, you just loop, but like go back to the, you jump to the loop start, the start of the loop, then you do some stuff after if it completes. So I think this is for ending it somehow. One is standard output. Mm-hmm. What is RAX doing? You write something into the standard output, and then you print that whatever you've stored in the digit. This is what the first 3 lines are doing. And the third argument is print 1 byte. Why do I need to print this 1 byte? You call the kernel. Yeah, then the whole block repeats as I mentioned. Then increment, then you compare, flag, then go back. What happens if it is equal to 10 in that case? So there are flags for each of those. Then there must be one for greater than as well. If it is telling, it's the thing is saying that there is a flags in the CPU that tells me whether it is equal to or less than whatever my comparing, whatever I'm comparing it with. So here, for example, I'm comparing the value of RBX with 10, right? So if I'm comparing it, it needs flags. If, for example, it was greater than equal to or less than or like whatever, then it needs separate whatever, like a separate flags for each, and those flags themselves need a new register. Kind of a waste, maybe, which exits the program. This exits the program. I'm sure. Okay, that was fun. Just wanted to type it and see what happens. Anyways, this is the code. This is the entire code. Jump to the top. This is the entire code, and I can run it again. Just for loop, and I have a loop. uh I think the next video should be. I'm not making any commitments. I'm just saying that the next thing is probably printing some sum of something, like adding two numbers or taking input and then adding those numbers. Uh, Looping or making like multiplication tables of an input of a given number, or like a number that I've taken from the user, maybe. Anyways, thanks for watching. What the fuck happened to my head?